Hi everyone. I apologize beforehand. My Serbian is not what it used to be. It actually never was. I could do this in Dutch because I'm Dutch, but I'm not sure if you would understand that, so I chose to do this in English. I hope you don't mind. My name is Roy Arends. I'm Principal Research Scientist. I work in the office of the CTO, the Chief Technical Officer within ICANN. ICANN is the Internet Corporation for Assigned Names and Numbers. And so my first question to you, have anyone not heard of ICANN before? And feel free to raise your hand if you haven't heard it. Oh, that's brilliant. Okay, so I don't have to introduce you guys to ICANN. My background is the domain name system, the technical part of the domain name system. It's also DNSSEC, that's the security part of the domain name system. Anti-abuse. So in that sense, slightly related to solicitors and lawyers. But my part in anti-abuse is basically to prevent the abuse of the domain name system before lawyers get involved, if that makes any sense. Also a big part of my job is to do analytics and statistics over the domain name system. So what is this about? I was invited by Jean-Jacques Sahel and Dusan to talk about the domain name system. However, they wanted someone technical, and I'm a techie, I'm a geek. But also I was asked not to be too technical in my presentation because I'm talking to lawyers. That's not meant as an insult at all. That's meant as a compliment. I have no idea about the legal profession. Never dealt with it in my life. The last time I used a solicitor was when I moved to England to take care of all the paperwork. So I apologize if it's sometimes too technical. Hopefully we get along fine today. So this is about finding the first host name on the early internet. And a couple of years ago, I gave a lecture in Cambridge University in England. And one of the students approached me and asked, what was the first name on the internet? And there's a little bit of internet folklore for registry people. Infamously, the first name on the internet was symbolics.org. That was the first registered name, registered through what was then called Network Solutions and now VeriSign. And that was really the first registered name. And I knew the answer, so I felt really good. I could give this immediately. And then the lady said, no. We all know this, but I'm talking about the very first name on the early internet. So this was long before there was a DNS. And me being a DNS person, I had no idea what this was. So project, right? I could go on through the archives of ICANN, trying to find that very first name. That also led me to understand why the DNS is there now. And this is everything to do with scaling issues, and we'll go through that in a minute. But keep in mind, this is not an academic exercise. This is at most digital archaeology. I hope that makes sense. I'm going to use some technical terms, but they refer to early technologies. So feel free to forget this immediately when you hear this. Some acronyms will come by, not important. This is just how they named the systems internally in the early days. So let's start with the very first host on the internet. So in 1969, computers were already established, of course, in 1969, and some universities had very large machines. So in UCLA is the University of California, campus Los Angeles. They had a very large machine, which is the SDS, Scientific Data Systems, Sigma 7. Like I said, forget this immediately, it's not important. It's just an interesting data point. These machines were very expensive. And these machines were also called hosts. So if you hear the term host name, it is related to that very large machine that had very few users, a fair amount of users on it. These users would use a terminal, which is nothing else than a screen and a keyboard that were connected to this host, hence the name host. So this machine would be in a very large room. These were very large machines. The terminals used to be in different rooms. And also these machines with a lot of noise, etc., etc. And the reason it's called the ARPA network, I'll go to that in a second, is because of the ARPA stands for Advanced Research Project Agency. This was established in very short, a very short history lesson here. This was established due to the Sputnik project in the USSR at the time. Because the USSR launched the Sputnik, the answer to that was a space race from the US, basically, and they created this research program. Research program invested in a lot of universities. Part of this research program was to establish a network. The reason for this network was mainly to be able to share the resources. Like I said, these machines would cost a lot of money, and if every university had to have one, and this would become very expensive very soon. So the idea was, what if one university could use the resources of many other universities? For that you need a network. And this is basically this is the birth of the Arpanet. On the slide you see two graphs. On your right you see the host, that was the big system, and on your left you see what is called an IMP. An IMP is a router or a modem, or nothing else than a machine that connects a wire to connect a telephone wire basically to a computer. And the IMP was delivered in September '69 to UCLA. This is that IMP, like I said, a very large machine. This is the actual very first IMP delivered to the UCLA. This is the machine it was connected to. The very first internet host, or ARPA host. After that, of course, the internet exploded, and we now have two systems a month later. You see here the very first Ascii Art, as we call it, as geeks would call it. It's basically a graph created by characters. UCLA was connected to SRI. SRI is Stanford Research Institute. And this, also a little bit of internet folklore, the very first message that was sent between these two systems was LO. L-O. And the reason for that was the folks in UCLA were trying to log in, L-O, trying to log into the system at Stanford, and they literally had someone on the other side of the network, right, on a phone line, and they basically say, I'm typing in an L right now, do you see it? The other side goes, yes, we see it. I'm typing in an O, do you see that? The other side goes, yes, we see it. And they typed in the G, do you see that? And then the network went down. So literally the UCLA system crashed. But that was the very first message, LO, on the early Arpanet. I didn't know this 3 years ago when I started looking into this. So I thought it was an interesting anecdote. So again, we have doubling the internet from 2 to 4 nodes, still 1969. Now we have Utah, University of California, Santa Barbara, etc. And Stanford Research connected. And quickly after that, this is 71, we now have many more nodes. And you can see you can see how things progress here. This is not doubling, this is an exponential growth, even at that time. So all these machines, these IMPs, they were connecting the Arpanet to all these other machines. These IMPs would have addresses, and these IMPs were delivered by Bolt, Beranek and Newman, which is a consultant company in Massachusetts. The addresses need to be registered, because you can imagine when you're sitting in Utah or when you're sitting in the University of Santa Barbara and you want to connect to another host, you need to know what to type in, right? You can't just arbitrarily call a system. So you needed, for instance, an account on the remote system. You need to know the address of the remote system. And you need to know who to call in the remote system in order to set up the connection. So, sorry, one more slide here for this. You can now see 1971, a little bit more nodes connected. This actually shows, this is the first reference I found to the problem of administering who owned what system. Because of this growth, and I will read from the slide, beginning with this RFC, Bolt, Beranek and Newman will report on the status of most network hosts approximately once every 2 weeks. if we do that now on the internet, if we register hosts once every 2 weeks, we shouldn't be in this business, we're doing it wrong, right? Once every 2 weeks, the information from these reports will be gained from talking to people at each site. And they could do that because Bolt, Beranek and Newman, that was the corporation that would bring all these imps, right? There was only one provider for these things, and that was Bolt, Beranek and Newman. Also from experimental data. And this data will be results of daily attempts to log into each of those hosts which might be accessible to a network user. If you do that now, on the internet, just trying to log into random systems, you would probably be arrested, right? Just an attempt, well, maybe not arrested, but at least you'd be on the radar. Because you shouldn't just blindly log into other people's systems without asking them first. And they would do this randomly at a random time each weekday. So that worked, right? When you have about 20 to 30 sites. And this is a list of those very first machines. Network address 1 would be UCLA, that's a machine we just talked about. And the contract there was with John Postel. Now John Postel was one of the fathers of the early internet. It's basically 3 people that were very important in the early internet. It was John Postel, there was Vint Cerf. Vint Cerf now works for Google. He wrote the TCP/IP protocol together with Bob Kahn. And the other person was Steve Crocker. And Steve Crocker is now the chairperson of the chairman of the ICANN board. He will come by in a minute. These machines need to have names. And here you have the very, very first host name on the internet, which is UCLA-NMC. So if anyone asks, probably no one will ask you ever this, but if anyone asks, the very first name on the Arpanet was UCLA-NMC. You can also see the alternate name. I see some people laughing. The alternate name was SEX or SEX. And this has nothing to do with what you might think it is. This is basically the name of the operating system, I understand, on the SDS Sigma 7 machine. So if you want to have a shorthand, you would type in SEX. If you want to have a standard name, you would look into your register for UCLA-NMC. You would find a telephone number, right? And that telephone number you would call, and you would ask the operator on the other side, can you please allow me to log in, or can you give me an account, etc., etc. Keep in mind, there was no web. There was email was basically machine-to-machine copy of messages. This is a geographical map of the very first Arpanet. The reason I'm showing this one, this is 1972, is it has the first connection over the ocean, and that was Hawaii. You see that on your left-hand side. 1973. Now London is connected. Did you see that to your right? When I'm talking to English folks, I will say London is connected, but since we're an international group here, London was connected through Oslo, so it wasn't really the first international connection. Traffic statistics. How big was the internet in those days? Very, very small. A whopping 60 kilobytes, right, per day, on average, right? This is the entire network. So not just between machines, this is the entire network, 60 kilobytes. Or in other words, a total of 1.8 megabytes per month. Right? That's very, very small. 1974, a German map, as you can see, because it says a topologische Karte, excuse my German. A little bit more nodes connected. Now we have the first scaling issues. You had 40 sites connected and 48 systems in total. Both Beranek and Newman at the time still did this thing every 2 weeks, but it wasn't enough, right? If you want to connect, if you want to use multiple systems, or if you were traveling to another university and you want to make use of their machines, and you needed to call home, you need to find those addresses. And it was awful, because you had no idea where you need to call to. And the sentiment is actually reflected in this piece of text, which basically says, now that we finally have an official list of host names, it seems about time to put an end to the absurd situation And by the way, as a geek, this to me is internet law, if that makes any sense. Protocol, right? RFCs reflect the protocols that we are using on the internet, and this is literally in an RFC. Can you imagine a piece of law text that would use the term absurd? I can't, but it was there. So to the absurd situation where each site on the network must maintain a different, generally out-of-date host lists for the use of its own operating system or user programs. And you can imagine, if you have 48 systems in total, every time you make a change, and you can imagine people move to different companies, students go to different organizations, etc., etc. There were a lot of changes at the time. Every time there was a change, right, every site need to talk to 47 different sites every time you make a change. This wouldn't scale very well, and this was recognized by the ARPA folks. The ARPA folks basically said, we're going to assign the registry of these systems to Ascii NIC. Ascii, again, Stanford Research Institute, NIC, Network Information Center. For instance, the Network Information Center in Serbia is .rs. At this time, 1973, it was Ascii NIC. Copies of the hosts file, this file would become very large, right? You could copy them through FTP. You probably heard of HTTP before. This is stuff that you type into a browser, http://. Well, at that time you didn't have HTTP, so in order to get files across between machines, you would use FTP, File Transfer Protocol. The Ascii folks would receive information from BBN, but also from other sites. They would make sure that names were unique. This is very important on the internet. That's why we have a registry, right? That's why we have many registries, to make sure that names are unique. This is when you come in, right? Where for instance disputes come from. If people claim if people claim that a name is actually theirs. Anyway, they also made sure that the names would be registered according to network guidelines, and they had a list of technical liaisons. This is that list, and this is where Steve Crocker comes in. Here you see Steve Crocker. This is 1974. Steve Crocker was manager at ARPA at the time, and you see here his telephone number. He probably won't answer the call if you call that number now. This is over 40 years old. But I found this a little bit interesting because my chairman of the board of the company I work for actually has his name on the very, very first host names table. Continuing, I mentioned Steve Crocker before. That's the guy on the right. The guy on the left is actually Vint Cerf. So Vint Cerf invented the TCP/IP protocol in 1974. He also was the chairman of ICANN at the time. But interestingly, if you're a conspiracy theorist, right? This picture is from 1966. Both men very well dressed. Well, they're good friends of each other. And this happens to be Vint Cerf's wedding, of which Steve Crocker was a witness. So that's why I have this picture. When I showed Steve this picture only recently, I got this via, very secretive. When I showed him this picture, he was like, "Oh my God, how did you get this?" And I told him how, and we had a laugh about this. Anyway, sorry. Continuing with the more important stuff. The very first disclaimer on an internet map. Right below you say, and I need to wear my glasses. Please note that while this map shows the host population of the network according to the best information obtainable, no claim can be made for its accuracy. Right? This is a legal disclaimer on a geek map. So, this is a little table that shows you the amount of internet traffic, and you can see things are really going fast here. Column number 11, that's on your right, or you can see it. That's the table on the right. Right below, in July 77, you have 10 million bytes going back and forth. That's a lot of traffic, even for that time. And this is, I understand, a daily average. Remember this picture? This is the Arpanet in 1977. If you look at this picture, this is 1982. That Arpanet, that very big picture I showed you before, is now this little tube in the middle that says Arpanet 10. And all these other networks that are around the world are now connected to, in 1982, to this Arpanet. Going further, you see again growth 1985, and now we really have some scaling problems. So now we have more than 5,500 sites, right? This is really a lot. That one big zone file that I talked about before, that ASCII file is now really big. 5,500 sites, right? And let's say one line per site. I know a text file now of 5,500 lines is not that much to many people, but at that time it was huge. Had telephone numbers, names of people, addresses, internet addresses, protocol numbers associated with it. And they were updated daily. Now the problem was, if you want to download this file, it would take a fair amount of time. But the bigger problem was, your machine, memory was expensive at that time, your machine probably didn't have enough memory to hold the entire text file in memory. So again, a scaling issue. These host files were downloaded every night from RNIDS, first via FTP and later via a specific protocol. And the maintenance of this very large file also had become cumbersome. Because every day, 5,500 sites, again, people moving jobs, machines get connected, networks changing addresses. This will become so big, so fast, so complex that you can't do this anymore over email, where you send basically an email, hi, we've changed name. There was no standard of doing this. There was no form you could fill out. It was just basically people, technical administrators, that would send a message to RNIDS, hi, we've changed addresses, hi, we've added some new machines, etc., and a bunch of folks needed to administer this. So another problem was the way you would use host names. You couldn't basically connect to a machine on the other side of the world that easy, right? If you want to send an email, you use something called Unix to Unix copy, or UUCP. And if you want to send email from this machine, let's say here in this building, right, or here in Belgrade, if you want to send an email from here to Stanford, this is the path that you would take. Not specifically this one, but USO, DECVAC, Harpo, Eagle, basically the hosts that you would send an email through. So if you would travel, if you move to a different machine, you can't really give a business card with an email address, because the moment you move, your path would be different, right? So your email would never reach the other side. So really time for a new system. This wasn't cooked up overnight. In order to come up with a solution, you need a bunch of requirements. These requirements are reflected in RC 799 and 819. The requirements were basically, the system needs to be fault tolerant. You can imagine that you don't want to have a system where you type in a wrong address and the entire network goes down. That's flawed design. You don't want to have that. It needs to be dynamic. What that means is, in order to make a change, right, not the entire system needs to be down. Scalable, you need to do this many millions more over. It needs to be redundant, right? So not just at SRI, you need to have this all over the place. The solution that is now the domain name system had a very interesting feature, and it was Delegation of Authority. This is why we now have a root zone. And the root zone is managed by PTI. That's the new name for IANA. PTI stands for Public Technical Identifiers. And IANA, this company, it's an affiliate of ICANN. IANA is the Internet Authority for Names sorry, I forgot the acronym. Addresses. Names and addresses, of course. Addresses, we talk about names. Thank you. That's why we now have an IANA, a PTI. They actually manage, for lack of a better term, the root zone. They administer the root zone. And in the root zone, that's nothing else than a file that has all the delegation for all the top level domains in the world. For instance, .rs, and the international domain name equivalent for .rs, that's .serb in Cyrillic. If I'm looking at my friend here, but also .uk, .com, .biz. We have many more new top-level domains, as many of you know. We have .xyz. We have the problem now is if I name them all, there are about 1,200. I understand, many more. But this was actually thought of in 1985. This is long before, like 10 years before we had the first web page. Also, a big problem now is at the time security wasn't considered. All of these things, if you type in a name, for instance, in a browser, and if you type in, let's say, example.com, and you would try to resolve that, anyone could be example.com. And that's why we now have DNSSEC, for instance. But in 1985, this wasn't considered. Anyway, this was a reflection of a very short history of naming on the internet. You now know why there is a domain name system. You also hopefully now know why it's designed like this, to be very scalable. I haven't gone into why we have registries and registrars and registrants. This is to make things even more scalable. Otherwise, for instance, you would have a single registry per country, like .rs. Or like .uk, which then has to deal with all individual corporations and users in a country. That doesn't scale very well. That's why you have registrars. Anyway, this was my very short presentation. Hopefully you've learned something. If you have any questions, I will be here not all day, but most of the day, I think. And thank you for your time.
Thank you, Roy, for your insightful speech. I'm really delighted that the audience seemed to be following closely and fully understanding your presentation, which was technical, but you did take into consideration that we are of a legal background. So I thought that it would be interesting to lawyers to perhaps learn or just refresh their knowledge on the beginnings of on the internet and the history of naming. And I'm sure that there will be some questions from the audience. We have 15 more minutes, so please do not hesitate to ask anything, well, almost anything, to our distinguished guest. Možete postaviti pitanje i na srpskom, mi imamo prevodioca, tako da... Yes, please, Professor Begovic.
Thank you very much. If we can go to the history of the first link between University of California, Los Angeles, and Stanford.
Yeah.
So basically, my question is, what was kind of link that was used? I would say a leased line. And then, at that time, there was still a monopoly of AT&T over the territory of the United States. So, what was the arrangement? Who was actually leasing that line? Was that university? If that was university, which one? Originating or terminating university, if I can put it in this way.
That's actually thank you for your question. That's a very insightful. That's a very insightful question. I honestly do not know the answer, but I'm going to find out. I'm going to talk to Steve soon. Steve Crocker is my boss's boss, and
Someone important.
Well, to me at least. I mean, he my day job, but I'm sure you find this question very insightful as well. I'll find out, and I'll give you my card. If you could please send me your email address, and then I'll make sure you get the answer, and I'll send the answer to Dusan as well. Thank you. That was a great question.
Probably ARPA project.
Excuse me?
Probably ARPA project. They had the money.
I think so. I know that it was at least line. I know that. Might even be just a box standard telephone line.
Yeah, but basically I don't see any, at that time, 1969, I don't see any other possibility than leased landline.
Yes.
Classical copper leased line.
Yes.
But I mean, it is the issue of institutional setup, how that materialized. Basically, physically, I would say leased line. Nothing else was available in 69.
Yeah. No, I think you're right. But the question is who initiated and who paid for it. It's an interesting question.
And at what price?
Thank you.
Thank you, Professor Begovic. Next question, please. Yes, please. Just use your microphone.
Thank you. I would like to ask a short question. How do you see the origins of the domain name servers and the declaration of the independence of cyberspace by Pierre Barlow? Because you mentioned in 1985 there was no security, or security was not considered. So in that sense, how do you see the independence of the cyberspace by the declaration coincide with the regulation of ICANN? Thank you.
Thank you for your question. There are many points in history that refer to as independence. For instance, when the Arpanet first became international, like I said, the connection through Oslo and London, questions were raised at the time as to the legality of that, because the network was built, bought, and paid for by the American taxpayers. Right, so now we have literally the University College of London connecting to this, and this was all of this stuff that was built in the olden days by Crocker and the likes. This all came from academics, right? From academia, from research institutes. Even though some of this was military money, right? All of this was considered open and available and reproducible. So also that is seen as independent, if that makes any sense. Really, I understand what you're referring to. The Declaration of Independence, I thought at that time that was very important, but we just had, and this is with my ICANN hat on, we just had a significant piece of independence from the United States government. And it was the end of the IANA contract. So now truly we have an independent, it's not governed by any country, it's governed, if you will, by the constituency of ICANN. And there we have the CCNSOs, the country code name support organizations. We have the GNSO, all these support organizations, and we have advisory committees. And they basically, the constituency of ICANN, they now govern, if that makes any sense, ICANN. So, in a sense, multi-stakeholderism at large, in a fundamental way, independent of any government. For instance, government is represented as well in its own advisory committee within ICANN, but is not more or less important than, for instance, the at-large committee or the Security Stability Advisory Committee. So, it's difficult to pinpoint the true independence of the internet. But it's very important to safeguard the independence of the internet. And also what is very important is to stop fragmentation of the internet. We know that some countries, and we can measure that, some countries in the world have some censorship. For instance, as a benign example, in the UK, and this has to do with copyright law, in the UK you cannot go to a site like the Pirate Bay. Independent if you want it or not, and independent if it's seen as illegal or not. Right? You cannot go there. So it erodes independence, if you know what I mean. So government slowly gets back into the picture. I'm not saying that we should not have this. I'm saying we should be alert and we should guard against single entities being able to control parts of the internet. Sorry for the long answer.
Thank you. We already have our next question by Mr. Jevtovic.
You mentioned John Postel
Yes.
And if I interpret things correctly, basically everything we as a registry, as a community, as an ICANN is doing was once done by John Postel.
Yes.
So maybe if you like to say a few words, I think it's very interesting person. I haven't met him, unfortunately.
John Postel was, and I think he started his career at University of Southern California, the Information Sciences Institute. John Postel took the responsibility on him to manage this SRI registry, to manage these things. Sorry, he started SRI, of course. Yeah, to manage this registry, if that makes any sense. This was not just a registry of domain names, but also a registry of, for instance, protocol numbers, or a registry of RFCs. So he was the very first RFC editor. The very first RFC was written by Steve Crocker, but he was basically the main person behind all of this. And as an example of his significance and his brilliance as well, when countries were connecting to the internet, or basically when universities, international universities, non-US universities were connecting to the internet, there needed to be a way to give, in the DNS, to give these countries their own string, if you will, their own identifier, like .rs is now Serbia, and .nl is the Netherlands. But he didn't want to become part of this political process. So he decided to take on him, so he decided to use a specific table. It's the ISO 3166-2 table, which is nothing else than two-letter country code table devised by the ISO committee. Now, this is used all over the world, not just on the internet. Right? If you look at license plates, not license plate. If you look at your car, there's a sticker probably, right? At least in my car, there's a sticker that says GB, not UK. In Holland, I had a car that said NL. It's not some country that basically says, oh, let's have this string. No, this is actually a committee from ISO that manages these strings. And John Postel had the brilliant idea to just use this table, so he would not get in any political waters. He would just refer to that committee for a new top-level domain. And I understand in 2007, 2008, when and I just learned this story this morning. Thank you for that. When .yu for Yugoslavia was retired and .rs came into existence. This is because, well, sorry, the RS, the string RS, was basically from this ISO table. And this was devised in, I think, 2005, 2006, when the string came in the ISO table. Yeah. Anyway, John Postel, together with Joyce Reynolds, these two people run the entire internet, basically until 1998. In 1998, two things happened. Something good and something bad. In 1998, something good happened, and that was a professional, the US recognized that there need to be a professional organization behind this registry. Because all of a sudden, 1995, 1996, the birth of the modern internet, commercial companies would connect to the internet. It was important that we got some legal backing, some proper administration, 24/7, etc., etc. So NUCO was founded. NUCO later became ICANN. And the bad thing that happened in 1998 was that John Postel passed away. So that was just so really John Postel was really the father of the internet.
I have, if I may, one small addition. It's also interesting for our community here because all .u domain name was originally assigned by a university in Slovenia, and when the Yugoslavia broke up, John Postel personally reassigned it to Belgrade, then unregistered association based in at ETF Electronic Faculty in Belgrade, and the administrator was Mirjana Tasic, and she is still working with the registry and she's still helping us with her experience. So it's kind of interesting parts of the internet history also happened related to our local history here.
Thank you.
Yes, in a way we have our Serbian John Postel, and that's Miss Mirjana Tasic. Tasic, that's it. Yeah. Do we have any other questions? Well, could I ask a question which is not related to the history of the internet, but to the presence? I think it would be interesting to mention, especially to the students, where are the main servers situated nowadays? If this is not a secret, but I'm sure it's not.
It is not a secret at all. If you think of what the main servers are, I'm going to talk about the root servers. There used to be 13. Not because 13 was a lucky number. 13 was the amount of names you could put in a DNS message, together with addresses, and a limit of 512 bytes. These systems were mostly in the US before 2002, I think 2003, mostly in the US, and some international. There would be one in London, there's one in Norway at the time. Nowadays, it's basically run by 12 organizations. One organization has 2 letters, a VeriSign. They run A and J. ICANN runs a root server. I think his name is LRoot. But we use a technology named Anycast. And this technology allows you to have a single IP address on multiple places on the internet. And thanks to this technology, in 2000, not exactly the date, thanks to this technology, we now have root servers all over the world.
In Belgrade also. In Belgrade also.
And Belgrade as well, indeed. So we have, at ICANN for instance, we have 240 systems over 140 locations. Combined, all the root servers, there are more than 1,000 around the world. I can't say that's enough, because some of them are seeing a heavy load. Some of them don't see any traffic at all. But really, we need this kind of redundancy. So these locations are all, if you're interested in this, there's a site called www.root-servers.org. It's a simple site, shows you where all the locations are. And the reason it's not a secret is because if you want to do some damage to the internet, you might be able to take down one location. It won't take down the internet. So that's why these locations are not a real secret. Thank you.